I'm Melanie Jean-Louis, and I work as a senior cloud engineer at Metadata Solutions. My background is quite varied. I started off in the public service, social service industry, nonprofit, to be more specific, and then I pivoted into cloud engineering. So I've been working as a cloud engineer and in cloud systems administration specifically for over 5 years now. And so it's provided me with some necessary skills to like work with large scale enterprises, um, infrastructure, and also managing the rising costs associated with innovation. So I'm happy to provide an introduction to how we can compel change with Cloud Custodian's infrastructure as code governance tool, C7N, left. And over the next 15 or so minutes, we'll cover four critical governance areas where shifting left delivers huge and immediate returns for both the finance and security teams. So, so here we have, I think we're all a part of the industry more or less. And Uh, I, I don't know about you guys, but some days I do feel like a janitor more than a engineer. Um, it's because waste accumulates fast, and a $50 a day error in the infrastructure at code costs nothing on day zero, but it costs $18,250 a year later. And you spend a lot of time chasing it down. So with this reactive model that uh, organizations are currently experiencing, we have a lot of friction coming from different angles. We have FinOps telling engineering that they're spending too much money. Security is telling engineering that their configuration is risky, and engineering themselves are getting frustrated fixing old work again and again. We can eliminate this friction by giving engineers the guardrails and the tools up front. The classic reactive model on the left involves getting alerts after costs spike or a security issue hits production. So that's the feedback loop where we get insights from our SEIM or SOAR tools during runtime, or the financial health report for unexpected spikes from a particular service. How do you change from reactive to proactive? Well, we'll use Cloud Custodian policies to validate IAC artifacts before the deployment. Shift left is about moving the cost and security conversation into the developers and engineers' workflow. We're not throwing away our day two cleanup rules, but we're complementing them by using the same custodian policies to check the IAC via GitHub. If if the IAC fails the check, then the deployment stops, or you get a warning so that the developers and the engineers can remediate and resend a new commit. This is immediate feedback and true prevention. So the goal of this session is to move to a proactive model by implementing governance before deployment. So that's the essence of shifting left. So here we're going to drill down on the technical advantages of using C7 and left to perform infrastructure as code governance. Cloud custodians infrastructure as code governance policies use the same human readable language for remediation at runtime with the environment and early in the deployment cycle with C7 and left. The the most specific change is pointing out the resource type, being Terraform, and then a cloud service provider. Here we embed C7 and left into infrastructure as code governance by enforcing consistency of resources in different environment stages at the same time. At pre-commit in the developer workstation, developers and engineers can validate their IAC artifacts based on best practices driven by our operational and security teams. At the pre-merge stage, we in the continuous integration pipeline where policies catch environment dependent configuration needs, and at pre-deploy in the continuous delivery pipeline where deployment is accelerated. So the first major best practice for enforcing governance at code is tagging. It's the foundation of FinOps, and without it, you can't allocate costs or identify optimization opportunities correctly. When you only have tagging in runtime, you always have a compliance gap. By enforcing it in infrastructure as code, the engineer gets immediate feedback. So you forgot the owner tag on this S3 bucket. You need to include your standard minimum tags according to your company's best policies. They can fix the YAML file and the policy will then pass after a next check. So there's no waste and no chase. When we look at in the right, we have a sample check tag policy that has some special features specific to C7 and left. We have the wildcard in the resource block. This enables engineers to have to cover multiple resources and over multiple cloud providers in one simple policy, as well as looking at the filters in the taggable resource. This simplifies the work by reviewing resources that are capable of being tagged. It reduces operational time, skimming through documentation to find out whether one or many uh, of one or many resource types support tagging or not. And this policy scans the IAC at the artifact level so that prior to deployment, we have a greater understanding and a notice to tag your resources at at development. This results in 100% tag compliance from day one and no need to change untagged resources later because the pipeline will fail. So shifting left within the FinOps perspective, and we're moving to resource modernization. On the development side, building reusable configurations is a pro in that from stage to stage, teams are building with the same core infrastructure. It is a reliant and automated system. So, however, this can mean deploying resources that have since been found to be cost inefficient. So, in our example, we have a focus on EBS volumes and migrating from GP2 to GP3. The costs of GP3 volumes are 8 cents per megabyte, and the cost of GP3 volumes are 10 cents per megabyte. This is like a 20% savings. And as you look at the GitHub Actions notice, you have your Terraform policy that's focusing on AWS instance, and it's checking the EBS block device for the volume type. It has GP2, and so the engineer understands that using GP3 volumes for better costs and performance um, it, it's better. So this would be more like a warning. It could also be a blocker. So when we're moving on to resource sizing, the environment layered protections for spinning up resources that are over provisioned at a sandbox level. So we're going to stop that by building a policy enhanced for specific resource types at each stage. When you create your GitHub workflows, you can branch off and create different jobs based on the branch and the environment. We can add specific policies for that. In this screenshot here, we have a policy that tells us that the development environments should use only a specific set of instance types. This saves money because in development and lower sandbox, we should be more cost efficient and then save the larger expenses for when the money is rolling back in production. Now we're looking at a policy that focuses on GPU instances. GPU-enabled EC2 instances are extremely costly. They cost around $30 to $40 per hour. Teams occasionally spin up these accidentally or forget to tear them down after testing. This policy adds a guardrail. It checks Terraform-defined EC2 instances before deployment. The policy here applies to the Terraform instance. And then when you look at the filter, we have environment.project. This is specifically taken from the project context so that if the project is not LLM training, this instance type should be blocked. It should only match to the specified instance type. So what's the benefit of shifting left in the minds of security? We have the security best practices, encrypting your resources, rotating your keys, logging, and providing least privilege access to your data. When we look at encryption, we have we have policies that have caught resources for SQS queues that have not been enabled with KMS keys. And that that gives it easy, sorry. So when we look at encryption, cloud providers make it easy to manage keys as opposed to bringing your own key and leaving it. Um, and so when we look at the policy here, we have an instance type that is not using the right form of IMDSv2. So there's a filter for IMVS1 and informs the engineer that this is not the best standard for the instance. And then again, the Terraform, the C7N left policy at the front is telling us we are not encrypting. We don't have the JMS, the James path parameter for um, for the SQSQ or yeah. Um, so I wanted to provide like some insight on how this will look like in via the terminal. You can see here that not only do we have we grab a resource block of the actual resource, from the Terraform file, SQSQ, but we also see how many um, how many policies that this particular directory would have scanned through infrastructure as code governance, and then we're able to have a easy visual example of which policies that need to be that have been caught, and it provides a lot of visual information and like data insights into how um, the infrastructure configuration is happening from an operational view. So what are like what are the best practices for implementing shift left? We want to start with campaigns. We should get buy-in from stakeholders across departments, create the GHA workflows that use IAC policies for yourself, and start getting familiar with the impact. So start with a warning, don't block right away. Maybe you'd want a policy that also has different actions based on the stage. And so yeah, maybe you want a policy that limits the sizing of the EBS volume at sandbox and dev. Yeah, also more robust and high cost resources at validation and production stage. So let's ease into enforcement by adding descriptive guidance for when authoring these IAC policies so that your end users can not only be aware of which lines of their Terraform files that needs to be updated, but also they know why, because most people appreciate the why detail as opposed to just know, and will take that knowledge into future code builds. So when it's said and done, and you have success with like a high priority, high costing issue, then you want to clear the way for more more feedback and more investment into your campaign. This brings like a lot of exposure to your governance, and it brings in more implementation. So here's some key takeaways. Infrastructure as code is the benefit of creating policies to review your infrastructure as code with Cloud Custodian. It provides the gift of awareness. While documentation and standard operating procedures exist for teams to review, having an active collaboration within the CI/CD pipeline keeps teams up to date on security protocols and best practices. So using IAC governance with Cloud Custodian, we eliminate a silo and add visibility. It is empowerment through proactive collaboration. The dev teams are able to respond to the guardrails instituted and provide feedback to operations and security teams on what works and doesn't in line with their business requirements. And lastly, shifting left transforms that janitorial role into an architectural commitment to cost optimization, increased security, and focused innovation. Thank you.
Thank you.